In this one, we're going to put what you've learned into practice in the context of a small project. So I've created a game. 80 to 9% of the requirements is going to be stuff which I've already taught you and we'll be able to figure it out that way. There will be, however, another, say, 10 to 20% of stuff that we don't yet know. And this is quite normal. When I'm working on projects in my day-to-day work, often I find myself having to go and learn stuff which I don't already know in order to complete the work. So whilst a lot of it I will already know, it's quite normal for you to have to go and do some extra learning in order to complete a project. So I think this will give us a good sense of realism. This is what software development's all about. It's about combining what you know with what you don't know and coming up with the best solution that you can. The game, in the UK, we call this Hangman. Whatever it's called in your country, it'd be great to know. Just put a comment in the discussion below. But what it is you have a phrase, one player comes up with a phrase and the other player has to guess what that phrase is. So I've called this file Hangman. Okay, and so this is how the game is played. So say I'm player A, I'm now going to enter a phrase for player B to guess. So I'll enter something short so we can demo this quite easily, and we'll just put London. We'll maybe keep to cities and locations. And now it says, player B, you must solve this phrase. Please guess a letter. So I'll say O. Okay, player B, please guess a letter. So if you get it right, you get so many lives, and you keep guessing until you complete it or until you run out of lives. So we'll discuss lives in a second. L. Now notice I'm using a lowercase l there, but it still finds the uppercase letter. So going back to what we learned in the last lesson, and then D, and then it says you win. Okay, so let's have a look at the requirements in order to make this game work. So there's really three phases. There's the game setup, i.e. where player A came up with the phrase, entered the phrase, and then displayed the blanked out version of the phrase which player B must solve. So we'll call that phase game setup, and that's what we shall work on first. But I'll still talk through the rest of it, just so you can maybe start thinking ahead at how you might solve certain things. So this next section, we'll call this game play. Okay, and so player B must guess a letter. If the guess is good, i.e. the character is in the string, consider case sensitivity. Like I said, I entered a lowercase l there, but that was still accepted. And if your guess is good, add it to player B's solution and replace the underscores with the correct letter which was guessed. And then show player B's solution. So you're showing them how many letters they've guessed of the phrase so far. However, if the player B doesn't guess the correct letter, we need to remove a life. So we'll start off with a certain number of lives, and then we'll show player B's solution again, and then let them know how many lives are remaining. And so whilst in the gameplay phase, we need to repeat the above steps while the user still has lives until a game end is reached. So have a think about how you might do that. Have a look at that phrase there. Repeat the above steps while the user still has lives until the game end is reached. So it looks like there's going to be some kind of iteration there. Game end. Okay, so there's two ways this game can end. The player B can actually get the correct solution, and like we did, in which case it'll say you win, or player B will run out of lives, in which case they will lose. So we'll run through this again, and we'll enter another phrase. We'll just say New Zealand. Okay, player B, you must solve this phrase. So we'll look at where we are in each of these bits here. Okay, player B must guess a letter. So we're now in gameplay. If the guess is good, add it to player B's solution, show player B's solution. So we'll do a good guess, E. Okay, so we've added it to player B's solution, and you can see it here, and we show player B's solution. Then we guess another letter, and so This time we'll guess a letter which ain't in it and we'll go with T. Okay, so T not found in, and then it says 2 lives remaining. So we've removed a life. We started out with 3 lives, by the way. We've removed a life and we've shown the player B's solution. Okay, and then you just keep doing that. So what I'll do is I'll just guess a load of letters which aren't in New Zealand, and then you can see what happens when the solution isn't found within the correct amount of lives. And so I'll go with Q, and so it says game over. The phrase was New Zealand. So basically player B has run out of lives. We've printed a game over message and we've printed the phrase, so we've let them know the phrase that we're trying to solve, and we've ended the game. Okay, so that's how it's going to work. In the next one, what we will do is we'll go and work on this game setup, which could be quite tricky. We need to convert a phrase into a blanked out version using underscores, but we also need to include spaces. For example, there we had a space in between New and Zealand, so we also need to consider that when we're creating the blanked out version. Could be quite interesting. Let's work on our game setup. So I'm going to grab these comments here and I'm just going to copy those, and then over in the Learn Python folder we'll just create a new folder in there and we'll call it Hangman Game. So Hangman Game, and then for each stage, we're going to have a game setup, we're going to have a gameplay, and we're going to have a game end. So I'm thinking what we'll do is we'll work on each piece by piece and we'll create a separate file for each part, and then we'll try and pull it all together. So it keeps us focused on just the stuff that we need at that time, rather than have a big file with a load of stuff on there which isn't relevant to what you're actually working on. It's all about just staying focused, really. So we'll call this one game setup. So create a new Python file, game hyphen setup. I'm just using that as all one word. And by the way, you'll notice that I've made the font a bit smaller for these recordings. If you notice the file there, when we had the big font is better on screen, it's better for teaching with, but when we had the big font, half of it was going off the end of the screen and we're having to do too much scrolling. So hope that's okay. We're going to keep the font that size for just for while we're creating this game, because some of these lines could get quite long. Let's paste in our little bit of text that we had there. Player A to enter a phrase, and then we want to convert the phrase into a blanked out version using underscores. Must be matching in length and must include spaces. Okay, so we'll not actually do the player enter a phrase. We'll just create a phrase and store it in a variable, and we'll work with that. And so what we shall do is we'll just call this phrase equals. Now we want something with a space in there, and we want something with capital letters in there also, or uppercase letters also, just so that we can test and develop this properly. So we'll stick with our trusty phrase, Python rocks. Okay, and now what we need to do is we need to figure out how we can take that phrase and blank out all of the characters. Here's version 1. So what I'm going to do is I'm just going to create a new phrase. I'm going to figure out the length of this. I'm going to create a new phrase which is just underscores, and that will take us part of the way there. So I'll call this new phrase, if I can spell it right, new phrase equals, and we'll just leave it as a blank string for now. So how are we going to do this? I need to know how long this string is, and then I need to make another string made up purely of underscores, which is the length of that string. And so the way I can do this is by saying underscore and then times. So if I was to do underscore times 3, and then I print new phrase. I'm not sure I've actually shown you this already, but what it will do is it will create 3 underscores in sequence. So let's go and print this out. Okay, and so we have 3 underscores. So what we want to do now is know the length of this string and then multiply our underscores by that. And so the way we get the length of a string is we do len and then the phrase. And so if I print that out now, we should have a phrase with a matching number of underscores to the matching number of characters in the original phrase. So I'll run this again, and that's what we get. Okay, and so this brings us to our next problem, because there is a space in there. How are we going to find out where the space exists in that phrase? So looking at it, we're looking at character, so 0, 1, 2, 3, 4, 5. So it's at character number 6, or it's at index 6, but how do we actually figure that out? How do we figure out where that space is? So there are a couple of methods which you can use on strings, and we shall try those out. So the first one is find. So if I was to say phrase find and then space, and then we'll just call this index and print that, then hopefully we should get an answer of 6. I'm just going to comment this stuff out. Okay, let's print this. Okay, and we get 6. However, what if the phrase had more than one space? So we'll call this Python rocks 2. Let's go and print this again. And we still get only 6. So we wouldn't know where our second space is, because all it does is it tells you where the first instance of the character that you're looking for. There is another method, and that is called index. And so this does pretty much the same thing. So we'll go and run this. Again, we get 6. But something to notice about these, and another thing which makes them unsuitable, apart from the fact that they only tell you where the first instance is if you're looking for a character which isn't actually in there, so I think E, if we go and print this now, we get a value error, substring not found. So this is going to start getting quite clunky. We're looking for, all we want to do is find spaces. Now we need to start handling errors. I'm already thinking this is probably not the solution for me. Let's see what happens if we use find. Okay, and we'll just go and run this again. -1. So if a letter isn't found, it gives you back an index of -1. This is starting to feel totally unsuitable. I think we need another solution. There is a function in Python which will look at a string, or it will look at a list, and it will give you back the value as well as the index. But what it does is it creates a certain kind of object called an enumerate object. So we won't be able to just access individual characters in it. You have to, an enumerate object is an iterable, meaning in order to get at those characters, to get at those indexes, you have to loop over it. An example is the best way to go with this. So what I'm going to do is I'm going to say enumerate object equals, and it's enumerate, which is a function, and then you pass it in the phrase which you want to enumerate. So when we say we're enumerating, we're basically giving a number to each of the items in that iterable. Okay, so if I print this now, you'll see that we get an enumerate object back. So I can't just access items in it like this, like it's a list or something like that. Type error, enumerate object is not subscriptable. In order to get at the items, you need to actually loop over it. Now normally, or up to now when we've looped over stuff, I'll just comment this out, is, say for example, I want to loop over our phrase. I would do for letter in phrase, and I'll just print out each letter. Okay, print letter. Okay, and so we get all the letters with the spaces printed out one by one. With enumerate, if I want to loop over the enumerated phrase, then I actually also have access to the index. So I can say for index, comma, letter. You have to get it in that order. It doesn't matter what I call these. I could call that foo, and I could call that bar, or I could call it anything. But you have to put them in the right order. But the main thing is we now have access for the index of each individual letter. Let's go and see what this looks like. And back to the terminal. And so, what do we have here? We have the index and the letter. So let's look for our spaces. 6, we have a space, and also at 12 we have a space. So this is perfect. We now know where our spaces are in our phrase. So what I'm actually going to attempt to do here is I'm going to loop over the enumerated phrase. I'll get an index and a letter back. I'm going to check to see if that letter is a space. If it is a space, I'm going to then use that index, and I'm going to try and enter a space in my new phrase at that index. Okay, sounds tricky, but it's really just doing this. So if letter is a space, then what I want to do, just like when you add items to a list, I'm going to attempt to do the same with a string. So new phrase index, so that will give me the 6th position in my new phrase, and I'm trying to now set that to a space. Let's see if this works. Okay, we get an error. Type error, string object does not support item assignment. Basically, we can't do this. We can do it in lists, we can't do it in strings. The reason being, strings are known as being immutable. In other words, once you create a string, you can't then go and replace letters in a string in the same way that you can replace letters in a list. A list is known as being mutable. That means you can go and replace items in the list. However, a string, once you've created that string, remains the same. It cannot be mutated. So we have a problem, and we need to come up an alternative solution, and we'll have a look at that in the next recording. Last one ended on a bit of a cliffhanger. We now have a problem which we need to solve. Let's just remind ourselves what that problem was. We were trying to add a space in an existing character at a given index, which we'd figured out using our enumerate function. But we got this problem here. If we go and run it, string object does not support item assignment. In other words, we can't just drop in a space in a string. Once you've established a string, then it is that string forever. You can, there are functions where you can create a new string from that one which has been adapted, but at the end of the day that will be a new string, and we are trying to put a space in an existing string. This is not allowed. So how are we going to solve this problem? The way I'd suggest is, you can't drop a space into a string like this. However, you can drop a space into a list. So how about this? We take our phrase or our new phrase, we convert this first into a list, and then we're working with a list, and we can then change the characters at certain indexes in a list, whereas you can't do that with a string. So let's actually give this a go, and we'll do it step by step. So first off, create a list of characters from new phrase. I'm going to let you have a go at all of these steps. I'll tell you what they are, but it's up to you to give them a go, and I would encourage you to give it a go. Don't just watch. It's by actually doing these things that helps you solidify the knowledge, and it stays permanent. So pause me now, give that a go, and then come back and see how we do it. So fairly straightforward. If you notice on the end I said letters list, that was just a suggestion of what we should call this. So letters list equals, if you want to convert a string to a list, you simply use the list function. So if you didn't know, I can't remember if I've taught you that or not, to be honest. If you didn't know, hopefully you had a guess at it or you Googled it. That will be the order in which I'd suggest do things. Have an educated guess first, and then if that doesn't work, go and try Google, and you'll probably see an example of that in this tutorial shortly. So letters list equals list, and then we pass in our phrase, and then we'll just go and print this out. Okay, so I want to print out new phrase. I don't want this bit to run here afterwards because it's going to throw this error, but at the same time I don't really want to comment it out or delete it. I just want to make sure that our program doesn't actually reach this line. The way you can do that is by throwing in a quit function, and that means that once our program reaches this point, it will just end. Okay, so let's go and print out our new phrase. In fact, we're not printing new phrase, we're printing letters list. So hopefully we should now see a list containing all of these underscores, which is the exact same count as the length of the phrase. Let's go and check this out in the terminal. Okay, this is looking good. So we have a list containing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, that looks good. Now let's move on to our second step. So I'm just going to remove these lines here and I'll paste in step number 2. Okay, replace the correct underscores with spaces in letters list, and this comment should go in here. So what we're going to do is do the same thing, loop through the phrase and enumerate it, and then instead of trying to replace a certain position in a string, replace a certain position in letters list. So this one should be fairly straightforward for you. Pause me now and give that a go. Okay, so basically all we're doing is, instead of trying to add a space in our letters in our new phrase, we're just going to add it to our letters list at the index where we find any spaces in the original phrase. Okay, so we're saying if the letter is a space, then at that index, which we are getting back from enumerate, we are replacing the underscore with a space in our letters list. Let's go and print this out and see what it looks like now. So print letters list. Okay, let's run this. Right, I can see spaces in there. Our first one, if you recall, should be at position 6, and I think the next one was 12. Okay, 0, 1, 2, 3, 4, 5, 6. Good. 7, 8, 9, 10, 11, 12. Okay, this is perfect. So all we need to do now is convert this list back to a string, and that is our third step. So this one might not work the way you think it would, but I'd encourage you to have a guess at it first, see how you get on. If your guess is incorrect, then the second choice is head to Google and go and see what you find there. So pause me and give this a go. Okay, so we've just looked and seen that you can convert a string into a list using the list function. So logic would tell me that I can then convert my letters list into a string using the str function. Let's give that a go, and we shall call this new phrase equals str letters list. Okay, and let's go on. We need to print it out, in fact. Print new phrase. Okay, and we still have a list. So that hasn't worked. We need to try something else. Over to Google, I googled convert a list of characters into a string. This led me to Stack Overflow. A lot of the times your Google searches will lead you to Stack Overflow, because this is where the most questions regarding code are posted. And as you can see here, someone's asked pretty much the same question I have a list of characters. How do I convert it into a single string? And the top answer is this one here. Use the join method of the empty string to join all of the strings together with the empty string in between it, like so. So they've started with a list which contains strings, and then what they've done is started with using an empty string. They've called the join method, which belongs to strings. Join is a string method, and all they've passed into the argument there of the join method is the list. And by doing that, they end up with this A, B, C, D. So all the pieces get joined together. Let's go and give that a go. Okay, so we'll get rid of this new phrase. In fact, we'll say new phrase equals. We'll start with an empty string, and then we are going to join. So join comes up there, and we are going to join letters list. And then we'll go and print out our new phrase. And there we have it. So we said that our phrase was Python rocks 2 Python space ROCKS space TWO. This is perfect. So in the next one, we're going to join up all this stuff and just complete. Now that we know how to make this work, we're just going to complete the game setup. We now need to finish off our game setup. We've done all the hard bits. We've figured out how we can actually display back a blanked out version of the phrase which player A decides. So all we need to do here is player A needs to enter a phrase. So we're going to need an input, and then we need to convert that phrase into the blanked out version using underscores and display the blanked out version. So really we've taken care of that middle part. All we need to do is for player A to enter a phrase, use whatever code we worked out for this bit, and then just display that blanked out version so we can print it. So 2 steps. I'll let you have a go at this. Player A to enter the phrase, and then using whatever's figured out with the code that we did here, we just need you to display that blanked out version using a print. So have a go at that, pause me. Okay, so phrase, instead of hard coding it, we actually need to use an input, and we need to prompt player A. So the way I did it in my solution is I put little square brackets around this, which I think is a nice little touch to show who should actually be performing the functions. So player A, please enter a phrase to solve. Okay, we'll do a little colon and a space, and that means it'll render better. And then all of this functionality takes place. We'll remove some of the noise, get rid of some of these comments. We've figured that out now, so we don't need these anymore. Okay, so then all this stuff will do its piece, and then we'll end up with this new phrase here, and we are actually already printing it out. So I think this should just work how it is. Let's go and give it a go. So player A, please enter a phrase to solve. So I'll go with Long Island. Okay, great stuff. And so it says we've got 4 characters there, space, then 1, 2, 3, 4, 5, 6, ISLAND. Perfect. We're now in the middle segment, which is the gameplay. So let's have a look at this. In fact, what we'll do is we shall copy this, and we'll go and create a file called gameplay. So in the same places where we create the game setup, which is Learn Python, Hangman Game, we shall create a new Python file called game-play. So game-play, and I'll just go back, copy that, paste that in there, and so now we have our steps. Let's talk our way through these. Okay, gameplay. Player B must guess a letter if the guess is good. So whenever you see words like that in like a technical specification or whatever, they're little clues. So I'll tend to either, if it's on paper, I'll underline them, or something like this, just capitalize them. So if the guess is good, i.e. the character is in the string. Remember to consider case sensitivity. So if you remember what we said, even if it's an uppercase letter in what player A specified, we still want to allow lowercase letters to find it. If the guess is good, add it to player B's solution. So we will replace the underscore in player B's solution with the actual correct letter that they've guessed, and we'll just display that solution so that they know how they're getting on, where they're up to. Else, so there's another keyword. We'll capitalize that. Remove a life. Okay, show player B's solution, so you're showing the solution with all the underscores, etc., and then let the user know how many lives are remaining. So you've just removed one, you need to let them know how many they have left. And this is an important bit. Repeat the above steps while the user still has lives until the game end is reached. So whilst you might receive some technical instructions like this, and a lot of developers will just start working away at their instructions in the exact order that they've received them. They'll just go head down, dive straight into this. But the biggest clue here is on the bottom line. Repeat the above steps while the user still has lives until a game end is reached. So we're looking at a while loop. So our while loop is going to run while the number of lives is greater than 0, i.e. the user still has lives. Whenever a player makes a wrong guess, we need to reduce the number of lives by 1. Okay, so before even getting into this guessing letters, showing the solution, what I would do is actually just set up a lives variable with 3 lives, and then set up a while loop which specifies a condition. Run this while lives is greater than 0, and then I would just print out the number of lives and also reduce the number of lives by 1 on each iteration, and that will just get that little piece of functionality in place, and then you can go and start fleshing out the rest of it inside of that structure that you've just created with the while loop. So I've already created the steps. I'll paste them in here. I want you to have a go at this. Okay, this is it. Initialize a lives variable with a value of 3. That's step 1. Step 2, create a while loop which runs while lives is greater than 0. Okay, and then inside of that loop, step 3, print the number of lives, and then step 4, reduce the number of lives by 1. So you can see how easy this is, just 4 simple steps. What I'd encourage you to do is when you're trying to work out a piece of logic, just do this, just write your steps, work through it one piece at a time, rather than just thinking you've got this massive application to build and trying to think too many things at once. Deal with one problem at once, okay? Write out simple steps, do one problem at once, and then write some more steps. So enough of me waffling. Give this a go, pause me now, and then come back and see how I do it. Okay, so initialize a lives variable with a value of 3. This is child's play to us by now. Lives equals 3. Okay, nothing difficult there. Create a while loop which runs while lives is greater than 0. You can actually just grab these last 3 or 4 words from there, copy that, go on to the next line, add a colon, and we now have a while loop. And so now we're inside of the loop. Number 3, print the number of lives. Print lives. Number 4, reduce the number of lives by 1. 2 ways you can do this, isn't there? Lives equals lives minus 1. So lives is now what lives was, except with 1 removed. So that's a long way of doing it. If you remember the shorthand way we did when we were incrementing values, we use this here, plus equals 1. Well, guess what? You can do the same when you're going the other way. So when we want to reduce lives, we can do minus equals 1, and that will just reduce the number of lives by 1. Let's go and print this out and see how we get on, or let's go and run this, I should say, and see how we get on. So we're in Python, and then it's Hangman Game, and then gameplay. Okay, and it just prints 3, 2, 1 because on the first iteration our lives is 3, then it reduces them by 1. So on the second iteration lives is 2, reduces that by 1. On the third iteration lives is 1, and then it reduces that by 1, which means that lives is no longer greater than 0, and so it breaks out the loop. That's the end. And so now with those simple 4 steps that we created, we now have the structure in which we can go and place the rest of our gameplay logic. So now we've got our loop going, let's go and place some of our logic inside of that loop, and that is how the game will run. So we had this if-else condition. Player B must guess a letter. If the guess is good, blah, blah, blah. Let's go and just paste this inside of our loop here. And so we've got a couple of bits. We'll indent it to make it easier for us to read, or to make it read correctly. So we're saying if the guess is good, and then if the guess is good, we need to indent this stuff because that's what's going to happen inside of the if condition. Else, remove a life, blah, blah, blah. And so this stuff needs to be indented. And then what we'll do is remove our comments from the last one because they're just getting in the way. So else, remove a life if the guess is good. So initially what we want to do is just get something working where we actually test this line of logic here if the test that the guess is good. So I'm going to reduce this down to 1 life because I just want it to run once and then actually break out of it. So you remember how to break out of a while loop? So I'll just put a break in there, and that means that it's going to run once down to this line and then break out because I'm really only figuring this bit out here. If the guess is good. If you remember how we look for a letter in a string, it's sort of like this, letter in string. Okay, we need to do something like that. So what we're going to do is we'll just create a couple of variables, and we'll say letter equals s, and we'll say example string equals string uppercase, because what I want to test is that even if we do use a lowercase letter, we need to consider that that needs to be included. We need to allow lowercase letters and not be so strict. So what we are now going to check for is if letter in example string, and then we perform our logic. So for the time being, I'm just going to print out a little success message, letter in string, which means we can go and look at our else side of this, else colon, and here I'll just print not in string. Okay, and it says remove a life. We can go and copy that. We might as well add this bit in here. And so, and we'll keep this here, print lives, because if we are correct, we've found the right letter, then lives should still be 1 when we reach this point, because we're starting with 1. However, if the letter isn't found in the string, then lives should be reduced by 1, which means but by the time we get to here, then lives will be 0. So let's go and run this. What do you think will happen? Will we hit this line or will we hit this line? And how many lives do you think will be remaining by the time we hit this line? Let's go and have a look at this now. So Python Hangman gameplay. Okay, so we get not in string and we have 0 lives. And that's the problem which we described. We're using a lowercase letter, but we want that to also be allowed. So, little challenge for you. Think back to the lesson. It was the last lesson before we started the Hangman game. What did we cover? And how can we solve that problem using what we covered in this lesson? Pause me and give it a go. Okay, so all we need to do is we just need to make sure that when we are checking example string that we're checking the lowercase version of example string, and so this time string will be converted all to lowercase, and so that means we should find a lowercase s in that string. Let's go and run this again. And so this time we get letter in string and the number of lives is still 1. So I hope you had a go at that and you were able to remember what we did. What we'll do now is we shall remove any comments that we don't need, just to clear up some of this mess. And we are removing the life. Okay, in the next one we'll now work on this. Add it to player B's solution. So we shall replace the underscores with the letter. Before we move on to that, have a think about how we might do this. We've done something very similar, haven't we? Because in our game setup, we replaced underscores with a space. So if we were just to go heads down and start creating a solution which replaces underscores with a letter now, we might be duplicating work which we've already done. So we've said here that we're going to add a letter to player B's solution, i.e. we're going to replace underscores with the letter. And we also said that we'd actually done something very similar to this, because we replaced underscores with spaces where appropriate in the game setup. So I'm thinking we need to avoid duplicating stuff here. So let's go and have a look at this code, and maybe we'll take it over to our gameplay section and we will see if we can actually reuse this for anything. So I'm just going to take the whole lot, go over to gameplay, and at the top here we'll see if we can figure something out. Okay, so let's have a look. We're looking really at this loop. So our letters list is a list. The phrase is the player A supplied phrase, and the character is an empty space. So really we can use this, and all we're looking to do is replace this empty space with the character that the user has guessed. So do we really want to have this piece of code in multiple parts of our application? No. Can you remember how we said we avoid this? We create a function which can be passed around and reused, and then you're just calling one line, i.e. the function call, rather than having to write multiple lines of code, which if you decide you want to change, you've decided you're going to go for a different approach with your logic, it means you've got to make that change in all of your code. Whereas if you've just put it in one function, it's all in one place, and if you need to make a change, you decide you're going to redo something, you make the change in one place. So let's give this a go. And instead of having an input, it's easier for development if you during development stages just use a hard-coded variable. So we'll call this example phrase, and notice I'm using uppercase as well, so we can test that logic as we're going along. Don't need that line, that means nothing, and these lines, yep, we'll need those. Okay, so let's create a function. What would be a good name for this function? I'm thinking, how about replace character in list, because that's what we're going to do. We're going to replace a character in this letters list. We're going to replace an underscore in the letters list. So replace, what am I doing? So we define a function with def, then replace character in list. Okay, and let's go and indent this, and let's think carefully about what we need to do now. So we're definitely going to need a phrase. This is the string that we are looking at to see if we have guessed a character which is in that string. So I'm going to change the name to string, actually. If I can spell string correctly, I'll change this to string. Okay, so now this is referring to this. Letters list, we will need that. Letters list. Okay, and then we're going to need the guessed character. So here we've hard-coded a space, but we actually want this to work for both spaces and characters which the user has guessed. We shall call this entered character because it's a character that the user has entered, and so then we are just changing this to entered character, and then letters list equals entered character. Now I have had a practice at this when I was creating the Hangman game, and you'll see in a minute that this isn't quite this doesn't give us quite the desired outcome that you would think. The last step that we need to do in this function is actually return our letters list now that it's been mutated. So this will be the new version with the character entered in place of the underscores. Let's give this a test drive. So letters list equals replace character in list, and our arguments are the phrase, so that will be the first one, phrase, and then the next will be letters list, and we did call it letters list, so letters list, and then finally it will be the entered character. We don't have an entered character. What I'm going to do is just for the time being I'll use E, because that's a good one because we have an uppercase E, and so it will test the logic. As you might have guessed, it's not quite gonna that logic's not quite gonna work yet, and the uppercase letters won't be replaced. Let's actually print out letters list, and we don't want any of this code below to run. We're going to come to that later. So what we'll do is we'll just quit after that line has executed. Okay, let's go and run this. So Python Hangman game gameplay, and it sort of worked. Like I said, the first character that hasn't worked, but the other ones, we have the E here on the end of example phrase and also the E on the end of phrase. That has worked. So how do we make it work where we can enter a lowercase character and it will also replace what were the uppercase characters? The way we do that is we just check if the lowered version of the letter is the same as the entered character. So if we run this again, we now see all three. So we have a lowercase e there for example, the last e on the end of the word example, then the last e on the end of phrase. However, if you remember when I demonstrated the game, we actually maintained if the first letter was uppercase, we kept it as uppercase. So what have we done wrong? What we've actually done wrong is we've added the entered character to the letters list. So the entered character is this here. We've guessed lowercase e. We don't actually want to add the lowercase e to the letters list. We want to add the actual letter which was in the string, in the phrase, as it was in the phrase. So we change this to letter, and with that one step we should see it the same way that it was created. So we now have an uppercase E, and of course these are lowercase. You might be wondering where the space is. Obviously the space won't be there because we've only been looking for the letter E, but just to prove that it will work with spaces, we'll look for a space this time and we'll run it again. And so as you can see here, we now have our space. And so we know we have a function that's going to work in all cases. It will work with the letters that we enter, and it will also work with any spaces which are in the phrase. So let's go and have a little bit of a cleanup, and we'll leave our function at the top of this file, but the rest of this stuff, we don't need that. But what it means is that we can now take this function here and we can drop a call to it in our code. So it will be this line here, and that's what we're going to do in the next recording. Alright, in that last one we came up with this reusable function. We said it's reusable. Places where we're going to use it are in the game setup, because we need to search for any spaces in the phrase which player A specifies must be guessed. And then we're also going to use it for the actual gameplay part. So any letters which player B guesses, that function is going to go and find those letters and replace the underscores in the solution with the letters that the player has guessed. So I think in this one we'll try and cover off this whole gameplay section here, and then that'll leave us with just to finish off the game ending and then piece all three bits together. So let's do this. We'll work on it piece by piece. Player B must guess a letter. So instead of getting into using inputs and entering letters we're still in development, we can drop those bits in last. Otherwise, we're back and forwards from the code to the terminal every time we want to run this and check our work. So what we'll do is we'll just hard code that part in there for now. Okay, and I think we'll change the name. We'll call this entered character. And so we need to change the name of it here also. So if entered character in example string lower, we can leave that how it is. Again, only going to keep it as one life because I just want it to run once just to see that the code I've written works and works the way that I expect it to. Let's remove some of the noise. We'll remove these prints here just so we've got as little noise and confusion on the screen as possible. In fact, we can get rid of all of these comments, can't we? Because they just play with your eyes in the end. Okay, and so we said we're going to actually drop our function into here, and so we're going to need a letters list. We're going to need to take part of our game setup where we take this and we convert it into a letters list. So let's go over to there. So we took the player A created phrase and we replaced it with underscores, and then we turned it into a list. So let's go and copy that bit from there back to our gameplay, drop that in there, and so new phrase. We're looking for the length of the example string. Now it's been replaced with the underscores, and then we need to convert that into a list called letters list. So this will work okay. So just to recap there, example string is we're mimicking what player A has entered, so pretending player A has said you must guess this word string, and then what we've done is we've taken that and created a string of the exact same length using underscores, and then what we've done is converted that to a list of underscores. Okay, you probably knew all that already, but I'm just not everyone will have grasped it quite as quickly maybe. So here we go. What we need to do is actually use our new function. So inside of here, and it's returning a letters list. So we shall say letters list equals replace character in string. The string we are looking at is the example string, and then next we are passing in the letters list, and then it will be the entered character, and so that will be this, which we're hard coding at the moment. We're not using an input, so entered character. Okay, so we're doing a bit of scrolling there because of the size I've got the font. What you can do is you can just hit enter after the commas, and this is still valid Python. Looks a bit strange, but at least it's all on one screen. And so add it to player B's solution and replace the correct underscores with a letter. Let's just print this out and make sure that that is actually happening. So we shall print letters list, and then what it will do, because the letter S is in the word string, then hopefully this condition will be met, and so it will run this function, and we should print the letters list, and we should see that the first letter, the S, has been guessed. The else block won't run, but what it will do is it will get to this part, because this is outside of the else block, because it's at the same level as indentation. So what we should see here is the letters list printed out and also the number of lives. Let's give this a try. Okay, good, just as I expected. So we have our letters list. The first character has been guessed correctly, and we have one life remaining. So that's pretty good. Let's now clear out some of the comments. We don't need any of this noise in here. And show player B's solution. So can you remember how we showed the solution, how we converted this letters list to a string of underscores? What I'll do is I'll pause this. I'll let you pause this now and have a go at that. Okay, so if you remember how we did it, we went and Googled how we did it actually, and we used a string and a join method. So what this does is it joins all the characters in the list, and in between each character in the list it uses what is here, but we're using an empty string, so there'll be no spaces or anything in between each character, and then the argument which you pass in to the join method is our iterable, and our iterable is the letters list. Okay, so let's go and print this now. So now you should see the solution, the S followed by a load of underscores. Let's make sure that that happens. Okay, perfect. Let's now actually move on to, so we'll leave that there. We'll print the player solution because that is what we said we would do. Now if it's incorrect, we need to handle the other side of the coin, don't we? So we'll use a letter this time which isn't actually in the word string, which means that this condition won't be met, so we'll never see any of this code run, and instead it will hit this condition, and so we need to handle this part here. So we're going to decrease the number of lives by 1, which we've already taken care of. Show player B's solution and let the user know how many lives are remaining. Now if you think back to when I showed you the demo, we handled this all in one line, so we're going to do that here. So print, and I'm going to use an F string because I'm going to drop in the number of lives, and I can do that by using parameters within the string if I use an F string. And also we need to show the solution, so we're also going to need to join this. We're also going to print this rather inside of our message. So that will look like this. F. We called it entered character, didn't we? So entered character not found in, and again, and so we're going to use this, but because we're using single quotes, we're going to have to use double quotes instead. So that's going back to one of our very first lessons on strings, if you think about that one. And then we need to say how many lives remaining, so we shall say number of lives, and then we'll put this in uppercase. Lives remaining. Okay, if I hit enter there, PyCharm will create another F string here. So that's one F string, and then by dropping onto another line, it just creates another F string, but you'll see in a second that it renders it just the same as if we'd done it all on one line. So in that one step, or in that one print, we've actually taken care of both these things. We're showing player B solution, and we're letting the user know how many lives remaining. Let's see what this looks like, because you don't always get it right first time. Sometimes there might not be spaces where you expect to see spaces, so always go and check your work straight away. Let's run this again. Said not found in blah 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 blah, 0 lives remaining. Okay, so we've got it pretty much spot on first time there. I'm happy with that, and I think now I can remove these comments. Let's get rid of some of the noise, and this is working quite nicely. We're looping through. Obviously we'll need to replace the bits that we've hard coded, but as far as the gameplay conditions here, this if else block is working exactly how we need it to work. I think now we can work on our game end. So we've got some parts in place for game setup and game play. There's a few bits which are hard coded and things like that which we'll have to remove, but we can leave those in for now. We know we have the functionality in place. Let's now go and work on the game end. And so there's two parts to the game end, if you recall. There's happy path, where player B guesses the phrase correctly, and so there we just need to print well done, end the game, whatever. And then there was part B where they run out of lives and we need to let them know that it's game over. So we'll deal with them. Let's solve one problem at once. Never think too far ahead, always solve just one problem at once, work in small chunks, pieces at a time. When you're happy that they are done, move on to the next part. So I'm going to copy this and we'll go over to our Hangman game folder, and we'll create a new file in there and we'll call it game-end. So game-end.py, paste those comments in there, and then we'll just, before we do anything, just analyze the requirements. Don't just go straight into writing the code. So obviously we're going to need some kind of if statement or an if statement. If player B has completed the phrase, okay, first off we need to figure out how do we know that player B has completed the phrase. So that's one thing for you to start thinking about. Print the phrase, we'll come back to that in a second. Print a well done message and end the game. So I'm just going to take these three bits here. I'm going to go over to our gameplay, and just underneath this while loop I'm going to put those comments in there. So print the phrase. Let's have a think about this for a second. We're printing the phrase here if player B guessed correctly. We're also printing the phrase if player B didn't guess correctly. So are we really going to need to print the phrase again? It's going to look weird, in fact, if we do. So let's actually not do that. Print a well done message. Okay, that's valid. We'll need to print a message. We'll just say you win, and then end the game. How will we end this game? So if you think about it, the way that this game runs is that while lives is greater than 0, it's just going to run and run. So if lives is greater than 0 but we still want to end the game, how would we do that? We'd use a break. So we'd drop a break in here. What we will think about first though is, how do we know that player B has completed the phrase? And the way we do that is, if the player B has completed the phrase, it means there will be no underscores in the phrase. So we need to check that an underscore is not in a particular phrase. So let's just create a phrase equals, we'll just go foo. Okay, and we'll do an if statement, if underscore not in, and then we'll say phrase print, and we'll just print our well done message because we need to do that anyway. So we'll just print you win. Okay, a couple of exclamation marks, and then we'll actually go and run this. So Python end. Okay, do you spot the mistake there? So what I've done is I've actually used that like that. By the way, that is a valid variable. We've covered this before, but that's not what we're looking for. We're looking for the string underscore. Okay, so let's try this again. You win, and then if I put an underscore in there, it means it shouldn't actually hit, or this condition will evaluate to false, and it means that then this line won't be hit, and so we should see nothing really in the terminal. And so that's exactly what happens. So we know that's working well. And I think we can actually now drop this into our gameplay. So let's go and just drop this in here. And so it always needs to run, gameplay needs to run first, and then we need to check for a game end on every occasion. So it's in line with the if-else statement which we've used for the gameplay. So that means that this condition will always be checked on each iteration of the while loop. If underscore not in, and so we're not looking at phrase, we're actually looking at this. We're checking that there are no underscores in the joined up letters list. Let's replace that in there, and then ideally we need to test this. I'm just going to remove some of these comments. And how can we test this? What I can do is just use a one character word, and I'll match it with the S, which means that there should be no underscores in the joined up letters list, and it should print you win. We also need to break. Okay, let's give this a go. And so we're running the gameplay file here, Python. Okay, so we're getting S and you win because it's printing, we're hitting this condition here. The entered character is found in the string. So what it's done, it's printed this here, and then it's checked if underscore is not in the joined up letters list, which it isn't, then it prints uwin and it breaks. So that's happy path. Now we need to look at the other side, i.e. what happens when the user didn't guess correctly. And we'll do that in the next one. We're now going to have a look at the side where the game ends, but it is because player B has run out of lives. So I think rather than going and working in the game end file, I think it'd be easier. Actually, I found it easier in the last one when we just worked directly in the gameplay file. So I'm just going to copy these comments over to that, and it's going to be underneath here. So first we're going to check to see if, like we decided in the last recording, we're checking to see if the player B has won. If not, we're going to get past that point and we're going to arrive here. And so this time we're checking if player B has run out of lives. So I'm going to let you have a go at this one. Only one stipulation I will say: instead of printing the phrase, so where here we printed this, we printed this, I don't want to show that. I don't want to show the underscores. I want to actually show to player B the phrase that they were actually trying to guess. So you need to show them example string. Okay. Apart from that, you should be able to work out these other stages yourself. You need to check if player B has run out of lives. So that kind of stuff's child's play too. Now print a game over message and print the phrase. Okay, I'm going to make this more clear. Print the phrase that player B was trying to guess and end the game. So I'm not going to give you any clues on how to end the game. I'm going to see what you come up with. So pause me now, give that a go, then come back and have a look at my solution. Right, first, if player B has run out of lives. So this is simple enough. This is child's play 2 now. If lives is less than 1. Okay, I'm just going to keep it at that. That's nice and simple. Print a game over message. Print game, put it in capitals. Game over. Print the phrase that player B was trying to guess. Okay, so we want example string. And then end the game. Okay, so whereas when player B had won, they had guessed all the correct letters, we had to break out because they still had lives, which meant that this condition would still have been true. However, we're now saying that player B doesn't have any lives, so lives will not be greater than 0. And so it is now not going to run. If we have hit this point here, we've printed game over, we've printed the example string, we don't need to break out because player B doesn't have any lives, so it's not going to run again anyway. So maybe you thought that, maybe you put a break in there, both would work exactly the same. You can put a break in here and they'll both work the same, but it's just one less line of code that you need, isn't it? So I'm going to try this out. Now we need to lose a life here, so we need an incorrect guess, don't we? And so I'll change this to Z and we'll go and run it again, and so we should see game over and we should see the actual solution being printed. We'll make the solution a bit bigger, we'll change it back to string, and that should do us. Okay, let's go over to the terminal and run this. So Python hangman game gameplay. Okay, Z not found in blah 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 blah, 0 lives remaining. So if you recall, that was part of our gameplay conditional. Z not found in, and then the version with the underscores gets printed and the number of lives remaining, and then we get to this part here, game over, and it actually shows you the solution, which is string. Okay, how did you get on? Did you manage to have a go at that? If you did, then congratulations. If you didn't, don't beat yourself up over it too much. You've received a lot of information from me over the course of doing this, and some of it is stuff that you've already learnt, some of it's stuff that you're still learning, or some of it's stuff that you might have you might have learnt so far back in the course that you've forgotten. So it's completely natural to forget these things. At the level you're at now, you're not expected to get all of the challenges exactly spot on. But as long as you're learning and you're progressing and you understand what I'm telling you and you can have a go at some of them, then you're doing really well. So what we need to do now is pull all this together. So we need to pull our game setup into this file here. I think that's what we'll do. We'll remove some of the comments and we'll run the whole thing as one go. So there's things we need to do, like we need to remove all the hard coding, and we also need to add the input to receive from player A what the string is, which is supposed to be guessed. So we'll do that in the next one. In this one, we're going to try and pull it all together. It looks like we've got all our functionality. There's just some things we need to clean up, and we need to glue it all together and make it cohesive. So what I'll do is I'll remove these comments from the top of the gameplay file. We don't need those anymore. And what we do need to do is get to the point where player A creates their phrase, and from that we end up with a letters list which is containing all the spaces as required. So let's go over to game setup and we'll grab some of the stuff from there, because we have the phrase, the player A input part, and that will be useful. And we'll just paste it in here and delete what we don't need. So phrase equals, and we decided we were going to call it example string, didn't we? And that's what we've used later on in our code. So I think we'll stick with that, example phrase. So I'm just going to change this to example phrase, which means we can remove our hard-coded one here. 3 lives, I think, instead of 1. And we don't need that line there. Let's see what we've got so far. Example phrase, and then new phrase equals, so that needs to be length of example phrase, and letters list. Okay. We can get rid of that. So now we'll have a letters list with underscores, I think. So what we'll do is we'll actually print it out to test that theory, and we'll just put a quit in there. So just in case that wasn't clear, what I'm expecting here is I'm going to enter a phrase as player A. I'll use one which has more than one word, so that we're actually working out the spaces logic, and then that will be replaced by a string with the equal number of underscores as there were characters in the full phrase which player A created, and then this will convert it into just a list. So our spaces won't be in there yet, we'll still have underscores for those. So let's go and print this out and see how we get on. Player A, please enter a phrase to solve. So I'll just put New York. Okay, and that's what we get. So N-E-W space Y-O-R-K. Good. So now what do we need to do? We need to use our replace character in list. And for the entered character, we need to say space. And what we shall do is we'll say that letters list now equals replace character in list. The phrase we are looking at is example phrase. The list is letters list. And the character we're looking for is a space. Okay, so what we're doing is now replacing any spaces or any underscores in letters list with spaces in the same index as where they are found in example phrase. And then we are returning a value, and we're again going to store it in a variable called letters list. So letters list is now a new variable, and it will contain our spaces, I hope. Let's go and run this again, and we'll use the same phrase. Okay, so N-E-W space Y-O-R-K. Great stuff. So that is good enough for us to make a start. Let's go and see if anything else needs to be replaced. Obviously this needs to be replaced, so we've hard-coded the letter Z. What we will do is we'll say input, and then we need to do a prompt. So we'll use the square brackets again. We'll say player B, please guess a letter. We'll use a colon and a space, and so that should work. That all looks good. And we just need to remove this break here. We don't need to print the lives there because we're printing all the information that we need now. So I think this should be good enough. Let's go and take this for a test drive. Okay, player A, please enter a phrase to solve. Let's stick with New York. Player B, please guess a letter. Okay, something is missing there. What we need to do is actually display the underscored version that player B is trying to guess. So what we shall say is we'll put a print in here, and I'm going to use an F string, and I'll say again I'll use square brackets because I'm addressing a player. Player B, you must solve this phrase, and then colon, and then what we're after is the underscored version. So again, I'm going to use the join, and I'm going to pass in a letters list. Okay, let's see what this looks like. And in fact, I'll put a little quit under here so we don't run the rest of it. I just want to check and see what this looks like when it prints out. So I'll run this again, quit that. So run the file again, New York, player B, you must solve this phrase. Okay, that looks pretty good, and we've got the three letters, one space, and then the 4 letters. Okay, that's pretty good. Let's go and run the whole thing now. So New York, player B, you must solve this phrase, please guess a letter. So we'll go with O. Okay, and we have a error, name example string is not defined, and it says line 17. So let's go and have a look at this. Entered character in example string. Error was telling us was that on line 17 we're trying to look for a character in a variable, but he's saying that that doesn't actually exist. And so I like to leave the errors in sometimes just to show you what happens. So we've used example string here, we've used example string here, we've used example string here. So I can't remember how we ended up using example phrase, but anyway, we need to change it. So I'm going to copy that, and I'm going to replace example phrase there. I'm going to replace example phrase there with example string. Again, I'm going to replace it there. And so I think we should now be good. Okay, let's go and try again. Please guess a letter. Okay, this is looking better. Let's try one of the ones which are uppercase, so we'll try a Y. Okay, and let's put that in as an uppercase Y, so looking pretty good. And so we'll go happy path here, and we'll actually complete the full thing. So we'll go with N, and we'll go with W, and we'll go with K. And so we see our message, you win. Okay, we'll do the same again, except this time I'll fail, and we'll see if we run out of lives and if that logic path works correctly. So again, we'll go with New York. Please guess a letter. So what I'll do is I'll maybe do a couple of correct guesses and then I'll run out of lives. So we'll go with E, and we'll go with U. So there's no U, 2 lives remaining. Let's go with Q. Okay, there's no Q, 1 life remaining. Let's guess one correctly. Okay, let's guess another correctly. And then let's run out of lives. So let's just go with S. Game over. S not found in blah blah, 0 lives remaining, game over, New York. So that wasn't really a very good message. What we'll do is we'll change this so it says the answer was. Answer was space, and then we'll just use a standard concatenation. Okay, let's go and run this again, and I'll again, I'll do it wrong. So phrase we're trying to solve is New York. I'll just guess a lot of incorrect letters. In fact, there is an O. And then one life remaining. Let's go with V. Okay, game over. The answer was New York. Okay, great stuff. We now have a fully functional game. Let's just go back and clear out any of our mess, just tidy things up if we need to. I've already done a lot of it, but I'll just get rid of this here. And maybe we'll actually put in some parts which explain which bit is which. So here we'll just say game setup. And then here we'll put and down here we'll just put a line in to say game end. Okay, good. So that should make it easier. If another developer came and looked at our code, they should be able to see the 3 different phases there and be able to work out what's going on. We don't need to put any more comments in there. It's all fairly self-explanatory, I think, and that should be good. So there, we've just built a little program of reasonable complexity. And like I said at the start, there was an element of realism in what we did, because maybe 80 to 90% of the stuff is things that I've already taught you, but maybe 10 to 20% is stuff that we had to go and figure out. We had to go and actually learn it in order to complete the project. And you'll find that with software development, that is just exactly how it works. So let's go through top to bottom our little program here and have a look at what we learned, what we looked up, and just have a little discussion about it. So functions, we came across a scenario where we had 2 pieces of logic in our code and they both worked pretty much the same, and so we thought back to what we'd learned about functions and how we solve the problem having duplication. You put the functionality in a function and then that can be reused. For loops, okay, methods, indexes and lists. We did some looking up because enumerate wasn't something we'd done before. We had a look at some options, we had a look at find and we had a look at index, but we saw that they only returned the first character that we were looking for, but we wanted to know the index of all of the characters that we were looking for, so we had to go and do a little bit of research, which was good. And then what we did here, we used inputs, so that's stuff that we've learned. I'm not sure, I can't remember if I've taught you this yet, where you can take a character and multiply it by a number, which is what we did here to get the exact length in underscores, converting strings to lists, and then we did our function call, which was pretty good. This was new to us. We have done methods, but we had to go and research how we can join up a list and convert that into a string. So that was pretty good. If you accepted that challenge and you went away and found the solution to that, excellent. We had a look at while loops, okay, and then we looked at a conditional, which was part of our gameplay, and we also combined something which we'd learned in the lesson before our hangman game, and that was to allow uppercase and lowercase letters, or to make it in case insensitive when we're searching for a letter, we can just call lower on the phrase that we are searching inside of. And then what we did was we used not in here. So this is something that we learned a few recordings just before the hangman game, the not negation, and also how to look in a string or in a list for particular values. And then we used break, which is what we learnt to use to break out of a loop. And then we finished it off by just checking a condition here, and we decided that we didn't actually need to use, even though we wanted to end the game, we wanted to end the while loop. Having thought about our logic, we knew that if we actually get to this point, we have 0 lives left, and so this condition won't be met or it'll evaluate to false, so we knew that it wasn't going to run again anyway. So if you had a go at the challenges, really well done. That's the way to learn, I find, rather than just doing course after course after course. that doesn't accelerate the learning. What accelerates the learning is actually doing the thinking yourself, I find. And so always have a go at the challenges. I try to keep them small because I remember when I was learning, if the challenges were big, I wouldn't do them. It would just feel too much for me. So that's why I try and keep them short, and I hope that encourages you to have a go. So I hope you've enjoyed working on this little project with me. I've enjoyed making it for you actually. It's been a lot of fun. Let's move on now and have some more fun.